Hello and welcome to the video for lesson 5.4, properties of mid-segments. You had the privilege of listening to the ping pong champion of South City over the weekend. I dominated like usual, although ping pong, kind of a nerdy, weird sport, so I don't know how too proud I should be. But today's lesson is pretty straightforward. We're going to do properties of mid-segments, which is something that's very straightforward, and then some algebra skills. So what I want you to write down is 5.4, properties of mid-segment, and then take down the notes that are on this page. The mid-segment of a triangle, and that definition is going to be the segment connecting the midpoints of a triangle, of the two sides of a triangle. So that's going to be midpoints. The mid-segment of a trapezoid is the same concept, but for a trapezoid, the definition for the mid-segment is the segment connecting the two midpoint of the two legs, and that just means the parallel sides. The parallel sides. So pause the video, write those down, draw the pictures, please. And to kind of get an idea of the triangle mid-segment properties, and they show you what the mid-segments look like. They show you that if you draw the midpoint of each side of a triangle and then you connect each midpoint, you form a triangle within your triangle, okay? And they do it one at a time, and they show you that what's going to happen is the three mid-segments conjecture. This tells you what happens once you make the three mid-segments. The three mid-segments of a triangle divide into four congruent triangles, or four equal triangles. And something we'll do in class is we will show that this is true. That if you do the mid-segments correctly, each one of these triangles, if you look up here, each one of these triangles is going to be equal to each other. And so it makes it into four congruent triangles, and each one of them are exactly equal. So please take down the three mid-segments conjecture, pause it if you need to. We also have the triangle mid-segment conjecture, and the triangle mid-segment conjecture, and you can see what it does. It creates, if I have a midpoint and a midpoint, that just means that it's in the middle, and if it's in the middle, it cuts that side into two equal parts. And so you look, it cuts those into two equal parts. So that's what a mid-segment or midpoint does, and the mid-segment connects the two midpoints. And so the triangle mid-segment conjecture, it says a mid-segment of a triangle is parallel to the third side and half of the length of the third side. That's important information, so please write that down and then think about it. It's saying it's both, the mid-segment is both parallel, and you can look at my markings once I switch this over. It is both parallel to the third side, and it is half of the third side. So if the third side's length is x, it's half of that. The third line's length, if the third side's length is 10, the mid-segment's length would be 5, because it's half of it. So pause this and get those down. The trapezoid mid-segment conjecture. That says the mid-segment of a trapezoid is parallel to the bases and is equal to the length. Okay, this is a little bit long. Equal to the length to the average of the lengths of the bases. The mid-segment of a trapezoid is parallel to the bases and is equal in length to the average of the length of the bases. So what it's saying is that if you have a trapezoid and you do the mid segment, that means you're taking the it's parallel to the bases. Which, think about what that means. That means it has to, the mid segments have to be on the non-parallel sides, because the midsegment is both parallel to the bases and is equal in length to the average of the length of the bases. So if this was 10 and this was 20, then that would be the average. And to find average, we do 20 plus 10 divided by 2 to get 30 divided by 2 to get 15. So this would be 15 because it's the average of the length of those. So pause this because I want you to kind of see. I want you just to write the trapezoid midsegment conjecture. Don't worry about writing this stuff. You don't need to write that stuff. It's just telling you that they're parallel. It's telling you that the average of the length of the bases is how long it is. And then it's saying the length of the midsegment. So the average of the length of the bases is just, this is a good equation. That is actually something I want you to write. The average of the length of the bases, B1 plus B2 divided by 2. And I would write it right underneath the definition. So pause that and do that, please. Here are some examples. You can pause these, and if you get these, for each one of these, it'll be 5 points extra credit that you get. I'm not going to go over them, but I will go over them in class. And so go ahead and pause and try to solve these if you'd like. Now what we're looking at, and we're going to finish off this video, is writing linear equations. You guys should have done this in Algebra 1, but it's things I want to go over, and it is part of the algebra review skills. And what you're looking at is, how do we know the slope and how to know the y-intercept? By looking at the equation. We all, hopefully by now, know the slope equation, y2 minus y1 divided by x2 minus x1. I mean, I've gone over that as often as they play Taylor Swift songs on the radio, which no one ever really gets sick of those. So they should keep doing that. But if you have the equation and you're trying to find the slope and the y-intercept, it's a different story. And we look at the first equation, y equals 2 plus 3x. The slope is the number in front of x, which is 3, and the y-intercept, which I'll circle in red, is the number that's not touching x. To get this to work, you have to have the equation as y equals. You can't have y on the same side as anything else. It has to just be y by itself equals. Can't be 2y, can't be 3y, you have to divide through. And so when you look, I said the slope is the number in front of x, 3, and you can see that that is true. And then I said the y-intercept is the number that's by itself, that's 2. That is true. And so you look, the slope of 2, and I want you to look at this graph, or when the y-intercept is 2, that's right here. The y-intercept is the point that it crosses the y-axis. Well, here's the y-axis. When that is 2, when it goes up 2, that's when the y-intercept is 2. So they're talking about this line, and if the slope is 3, they go up 1, 2, 3, and over 1, and that's how you draw your line. And you can do that for all the other ones. Over here, you look, and the slope is 2, because that's the number in front of x, and the y-intercept is negative 1. You have to include the signs. Slope of 2, y-intercept of negative 1. So when we're doing y-intercept of negative 1, we go to the y-axis, we go down 1, and that is our y-intercept right there. And the slope is 2, so we go up 2, 1, 2, over 1, and you see that's how we draw that line. And you can see that that's what we do for the same things. Negative 3, 4. Negative 3 is the number in front of x. 4 is the number that's not touching anything, that's the y-intercept. Now, negative 5 is the y-intercept, and 3 halves x. If it's 3 halves, here's negative 5, that's our bottom one. And if it's 3 halves, that means it goes up 3 over 2. It's y divided by x, up 3 over 2. So, y equals mx plus b, where m is the slope and b is the y-intercept. I do want you to write this down here. I want you to write that line. So pause that video and write that line, please. To graph a linear equation, the slope-intercept form of a line, y equals mx plus b, m is slope. I do want you to write this as well. And b is y-intercept. The point-slope form, you need to write this equation, but you already know m is slope. So all I need you to write is this equation. x1 and x2 is any point on the line. x1 and x2 is any point on the line. So to graph a linear equation, this is the other thing I want you to write. So write this, and only need to write the equation for this part, and then write these steps. This is going to be good to know. So pause this. And then here is some different graph, each graph of a linear equation. We look, I'll do one of these. Here's the slope is -2. The y-intercept is 1. So at the y-intercept, I go to the y-axis right here. I go up 1. That's my starting point, my y-intercept. The slope is -2. So instead of going up 2 and over 1, I'm going to go down 2 and to the right 1. And then that is going to be my slope, or that's going to be my line. And you can do that for all of these as well. So pause the video because I think we only have a couple more slides. Yep, only 2 more slides. To write an equation from a graph, find the slope of the line, solve for the y-intercept using either point of the slope, and write the equation. You should have already written this. So this is just giving you an example of a graph, and then it's saying write an equation for the line. So now if they give you the graph and you want to write the equation, you go to your y-intercept. They give us the point, 0, 2. That means our y-intercept is 2. So it's y equals something x plus 2. That's our y-intercept. And our slope, it goes down 1, 2, 3, 4, and over 1, 2, 3, 4. So the slope is 4 over 4, which is just 1. So your equation would actually be y equals x plus 2. Now we look at this one over here, the y-intercept. It doesn't hit an exact point. So for this one, you'd use point-slope form because you're going to use a point and the slope. So you find your point, it goes down 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 6/13 the slope. X minus x1. Well, what is x1? You can pick either of these points. I'll pick 8, 2. That means x1 is 8. And it equals y minus y1. Well, if I picked 8 as my x1, 2 is my y1. And that's my equation. I could solve it for y if I wanted to. To write an equation given 2 points, write this. This is what I want you to write. And then you're done. So pause this video. Hopefully you understand both of these concepts, and we will work on these in class.